Hi everyone. Welcome to class. First, apologies for my voice. I think I'm feeling a little allergy in the past few days and so bear with me today. And so far we talked about data modeling in relational databases, and we mainly talked about the entities, what entities are, and how they are going to be our tables in our database later, what are the attributes, and we talked about also about different types of relationships such as one-to-one, one-to-many, many-to-many, primary keys, foreign keys. So these are the things that we discussed so far with a few examples. Now, today I'm going to further go into further details of different types of entities, different types of attributes. We will use ERDPlus together. ERDPlus is a tool online tool that I use to draw ER models. It's free and I found it easy to use. If you would like to use any other tool, that's okay. And so, in terms of entities, so these are the different types that I'm going to discuss today. So for the entities, we will discuss the regular entity, such as, for example, students, employee, and so on. Associative entities, which we discussed last session. Weak entities, so could be like regular, could be weak entity, could be associative entities. For the attributes, we will talk about different types of attributes, like multivalued attributes, like normal or regular, multivalued, composite. This is also called composite, and please do not confuse them together. This is composite attribute, this is composite entity. And then we'll talk about derived attributes, and so on. And then we have different types of relationships, right? For example, one-to-one, one-to-many, many-to-many. And so, just to summarize what we discussed before, what is an entity? Someone tell me what is an entity? Give me an example. Yeah.
Something that collects data.
Something for which we want to collect data. Or can you be more specific? Like, give me an example.
Example would be like a student or.
Yeah, for example, we would like to store student information in, let's say, database of university, let's say, registration system, right? We want to keep track of the students' information such as name, email, grades, and so on, and then so we'll need an entity for students. And in each entity, we only include the attributes or characteristics or features that are specific to that entity, right? For example, in the student table, we would like to keep the student information, not supervisor's information, not class information, right? Not course information. For all like these things, we'll assign separate entities. So separate entity for a student, separate entity for classroom, separate entity for the course, separate entity for the employee, and so on. Now, these are all regular entities. And then once we are talking about the relationships, we said sometimes we have many-to-many relationships. So before going to many-to-many, I start from one-to-one. One-to-one is like the basic one. So for example, we say each let's say just this is very fictional, but just to give you an example. If we have if you say each employee can work in one department, and in each department we can have only one employee. If that was the case, I know it doesn't make sense, but if that was the case, then it's a one example of one-to-one. Okay? Most cases are one-to-many or many-to-many. For example, we say each employee can work in only one department, but each department can have many employees working in that department, right? So this is an example of a one-to-many. Or if you say, for example, each student can enroll in one or more courses, but each course can have one or more students enrolled in that. So this is an example of what? One-to-many? Is this an example of one-to-many? Relationship between a student and course. So each student can enroll in one or more courses, and for each course we can have one or more students enrolled in that course. Example of? Many. And for that we introduce associative entity or composite entity. Now today, when I'm talking about different types of attributes, I'd like you not to confuse composite attribute with composite entity. So these are different things. This is the type of entity, this is the type of attribute. Now, to handle, and we discussed why we cannot handle many-to-many relationship in relational databases, and how we are using foreign keys to link tables, right? For example, if we have a one-to-many relationship, let's say each professor can supervise only one student. So this is a prof, this is a student. So if our assumption is each professor can supervise, 0 or more students, and each student can be supervised by only one supervisor. This is an example of one-to-many, right? So each prof can supervise 0 or more students. Each student can be supervised by one and only one prof. And I'm going to explain these two signs today. So this means optional, and this means mandatory. And these signs, right? This is for many sign, and this is for one. Now, what do I mean? So when we say this is a one-to-many relationship, first, one-to-many, it means that we have to put the sign of many here. And what is that? This is the many sign, right? So this so far only show me that that each professor can supervise multiple students, right? So this is a prof, this is a student, right? And this is their relationship. And this is supervised relationship, right? So each prof can supervise multiple students, right? So this is a many sign. So this is a sign for many. And each student can be supervised by only one prof. So we put the sign 1. Now so far, this is not complete. Because if I ask you, can we have a student that is supervised by no prof? Or can we have a prof that supervises no students? Can you answer that based on this? No. We only know that each prof can teach multiple students. Each student can be supervised by one prof. Now, in order to see whether this we call participation is optional or mandatory, we have to use these signs. Okay. So, if my assumption is each prof can supervise no students, one student or more, because we may have some research stream profs and teaching stream profs, maybe the teaching stream don't want to supervise a student, right? So in that case, in my database, I have some professors who supervise 0 students or no students. So this is an example of optional participation, and we show it like this. Okay, so this means optional. So this means each prof can supervise 0 or more students. Now, from the other side, we said each student can be supervised by one prof. Can we have a student that is supervised by no professor? Again, it depends on your assumption. If in your assumption each student should have a supervisor, then this is manageable. Okay? Now, we can have different combinations of participation, which is this is optional and this is mandatory, right? With types of relationships. So for instance, we can have, if you consider different things, we can have something like this, or this, right? Or this, and this. So these are the things that we can have. And so it's about the type of the relationship. And then we discuss the many relationship, and that in our databases we can handle them, because for instance, when you have a one-to-many relationship like this, you already know, so all of you should know which side you have to add the foreign key, right? So my question, what is a foreign key? Yes?
So it could be the primary key of another entity.
Yeah, to complete it, that we use to link the tables. Okay, so it's basically a primary key in another table that appears in primary key in one table that appears in another table. So for instance, what could be the primary key here? Let's say the unique identifier for this entity is prof ID. Okay, so this is a unique identifier here, which will be your primary key in the professor table later. And then you also have some other attributes. And then we also have several attributes here, right? Such as a student ID, which is again the unique identifier here, because no two students can have the same student number or student ID, right? That's unique for all the students. Now, we said primary key of one table or entity will become a foreign key in the other table. So which one should be added to the other one? So if I'm going to have a table for prof and a table for students, right? So in the student table, I have a student ID and name, right? A student ID name. And here I have the prof table with prof ID and name and email and so on, right? So how to link these two tables? Yes?
Prof ID goes in the student table.
Prof ID goes to student table, exactly. And we know why, right? Because if you just want to memorize it, which I don't recommend, you always add the foreign key to the many side of the relationship, and the many side of the relationship is a student table or a student table. So you have to add the prof ID, which is the primary key here, as a foreign key here. If you want to really learn it, it depends on the type of it's about the type of the relationship, right? We said each student can be supervised by only one prof. So in this case, we don't have problem with atomicity or storing multiple values in each cell, right? Because each student, let's say student 91, is supervised by only, for example, this prof. Student 92 by another, and so on. However, if you wanted to add the student ID to the prof table, you had problem, right? Because each prof can supervise many students, right? And so here you had to deal with storing multiple values in one cell, which is not allowed. Or if you wanted to store them in multiple rows, then you have like redundant or repeated rows. So we said in order to so we know that. And then it's okay, now let's say we have a many-to-many relationship such as a student and course. In that case, the issue is you cannot add the course ID to the student table, right? Because each student can enroll in many courses. So that's not possible. And if you also want to add the course ID to the student table, it's the same. So adding the student ID to the course table or course ID to the student table would result in the same problem. Are we okay with that? Yes? Okay. So we introduced associative entity, right? So we introduced associative entity, so we had course here, and we knew that they have a many-to-many relationship, right? So we added associative entity here, which was for the enrollment, right? Now, can you tell me what is this relationship? Now that we added the associative entity, we have to also correct here, right? Because we broke down the many-to-many relationship into what? What does associative entity do? Yes.
It makes it into a many-to-one.
Yes, it breaks down the many-to-many relationship into two one-to-many relationships. So now we have two one-to-many relationships. Now you tell me what are the signs that I have to use here? So I help you. For a student and enrollment, let's focus on that. Each student can appear in multiple enrollments, right? Because you can enroll in several courses, so each student can appear in multiple enrollments that are related to different courses. So, what should I do? Yes.
One-to-many?
One-to-many here, but where should I put the many side?
To the consonant.
It's here. Okay, so because I see people get confused here, so just want to practice more. So the many side come here because a student can appear in multiple enrollments. And then each enrollment in the enrollment table, so if this is your enrollment table with a student ID, course ID, and let's say grade, okay, this is the enrollment table. Now in your enrollment table, you have student ID 1, course 3401, right? Student ID 1, 3421, and student ID 2, 3421. So both a student ID and course ID can be repeated in the enrollment table because none of them is primary key here, right? But together they form a composite primary, which means a primary key that consists of more than one column. Now, this combination is not repeated, but each of them alone can be repeated. Now, each student can appear in multiple enrollments. What does that mean? What is each enrollment? Where can you find each enrollment?
Like each row?
Each row of the enrollment table, right? Same as, for example, a student table. What does each row represent in a student table? Each row in the student table is an instance of that entity, right? Is a student, one student. Each row in the course table is specific to one course. Now, this is the enrollment table, so each row represents a unique enrollment, right? Now, we have a unique enrollment in each row, and we said each student can appear in multiple enrollments, right? This is a student ID 1. As you see, it appears this student appeared in two enrollments in my table, right? One is related to course AI, the other is related to the database course. And how about the other way? For each enrollment, how many students can be appeared? You can check it with the table there, right? Each row in the enrollment table represents an enrollment, a unique enrollment, right? So each enrollment, can we have for each enrollment multiple students?
One student.
One student, right? Because each enrollment, which represents a specific row, a separate row in the enrollment table, is specific to a course and specific to a student, right? So this should be one. How about in terms of their participation, like whether they are mandatory or optional? So can I say, for example, can we have students that have 0 enrollment? If you want to allow that in your database, it depends on your assumption. So that's why for your assignment, both assignment and your group project, you have to be very specific, and your ER model should reflect what you write in your business models and business rules. So for instance, if you say, okay, each student can have 0 or more enrollments, then this is how you have to show it. if in your assumption you mentioned that each student should be enrolled in at least one course, right? Then you have to show it with this. Okay? So this means each student should be enrolled in at least one course, but can be enrolled in multiple courses as well. How about the other way? For each enrollment, can we have 0 students? Can we have an enrollment but not a student? No, that is not possible. So if this one doesn't depend on assumptions, you cannot make like incorrect assumptions. So this is mandatory, because if we have an enrollment, it means that there was a student and there was a course. So from this side is also mandatory. Now the other way, the same. So we say for each course, we can have multiple enrollments, because several students can enroll in the course, right? So this is the many side. And each enrollment represents one and only one. Now from this side, again, it depends on your assumptions. Can we have a course that have no enrollments? This is like not really, like, doesn't make sense, that this assumption, right? If we are offering a course, we want to have enrollments. If it doesn't have, maybe we remove that course, right? So this is also mandatory. Is this clear? Mandatory, optional, one-to-many, different types, yeah?
I also wanted to know that when we have a many-to-many relationship, we should try and break it down into a one-to-many relationship.
Yeah. So, like here, so we had a many-to-many between a student and course, and we broke it down into 2. This is one-to-many, right? This is also one-to-many. And that's it. So, this is about associative entity. So we also explained that. So associative or composite entity. So both are the same. Okay. So if I mention composite entity, same meaning as associative entity. We can see that explain later. Now let's talk about different types of attributes. So far we've seen mainly like just regular attributes, but sometimes we have, for example, an attribute such as phone number, for example, that you can assume that a student, employee, a person can have more than phone number, right? And so we call that the multivalued attribute. So this is, for example, let's say student's phone number. And how do we show it? Using double line over. Okay. So this is how you show multi-valued attributes. We'll practice with it in ERDPlus more. And you can assume like, if for example, for whatever attribute that you can allow 2 values, 3 values, like more than 2 values, you can consider that a multi-value, such as phone number. So it could be like different things. And sometimes email as well, if a student can have like 2 different emails. But in terms of like the university database, so every student can have just one unique email. And composite attribute. So please do not confuse it with composite entity. What is composite attribute? An attribute that is composed of several other attributes, such as what? Let's say you want to store a student information such as student name, phone number, and address. Okay, so you know how to store student's name. That's easy. It's just like 1 column in your table, and it's just a regular attribute. Phone number is a multi-valued attribute, and I'll let you know how to handle that. And address. How do you do with that? We call attributes such as address that are composed of different parts. For example, for address, we have a street number, right? A street name, zip code, and so on. So it's composed of different parts, and we call that composite attribute. Okay, so address could be an example of that. And how do you show it? So let's say this was the props. So if you have an attribute address here, you put it in the parentheses, and then it is composed of different attributes itself, such as a street name, a street number, right? Maybe zip code, and so on. So different components of the app, and we call it a composite attribute. So I'm going to show all of these to in ERDPlus so that you can practice with that. And one more attribute is derived. So the name, as the name suggests, the derived attribute is an attribute that you don't have the value in your current table. So for example, you have a table of your employees. You have your employees' data such as name, date of birth, and so on. But you, like later in your analysis, you frequently want to use employees' age. Okay, you have the date of birth, you have today's date, so you can calculate age, right, and add that column. So even in data analytics, you have similar things, right? You have feature engineering, adding columns, creating new columns based on other columns. So we call these attributes derived attribute, which means its value is derived from another attribute. So age is a good example of a derived attribute because if, for example, if in a table you have date of birth and you want to have age, then you can calculate age based on date of birth, and then this will be an example of derived attribute. So I think we covered this composite attribute and derived attribute. And the only thing that is remaining is weak entity. So I'm briefly explaining that, but I don't want to overwhelm you with different types. I just want you to learn these things in the examples. But for now, a weak entity is an entity that doesn't have a unique attribute of its own, or it doesn't have its own primary key. That is one condition. The other condition, because you may say, okay, if it doesn't have a primary key, I'm going to add a unique identifier such as surrogate key, and then it's unique. So that's one condition, but it also should depend on another entity for its existence. Okay, so these are the two conditions. And one example. So let's say I'm talking about the different sections at your university. Okay, so I have a question. How do you think we can design and how we can take care of different sections of different courses in our model? So for instance, we have database course, and we know that for each course we have a table, right? So we know that we can find, for example, database in the course table. Now, what if we have different sections of the same course, such as, for example, database section M, section N, and again, section M and N can appear for other courses as well, right? We can have machine learning section M. We can have Python section ABC, but we can also have AI section ABC, okay? Do we consider a separate entity for sections here? So how do we deal with this? Do you think,
Would it be a multi-valued attribute?
Multi-valued attribute. And how do you want to store that in your tables?
You'd have section, and then it would have different values, one for each section.
So you have a table for that. You want to store it in which table then?
Of the course.
So in the course table, so what are the columns? Course ID, course name, and then
section, and then that would be a multi-valued attribute with the different sections in that column.
so how do you deal with that? So let's say we have, so it's good to think about these things later. So let's say this is your course tag, right? So course ID, course name, and this will be the section, okay? So course ID, let's say 3421, which is the database course. We have section B, right? And then we have 3421, section A. So this is a course title, right? What is the unique identifier in the course title?
Wait, so the primary key would be the course ID and the section?
The primary key could be the course ID and the section. So you can design you can design the course section in your database depending on what is represented in different ways. So for instance, if each section can represent unique thing, right? For example, if you have, for example, when I say section A, section B, section C, if they have a meaning, if they have different features, then in that case, which is not the case in the York University's database, you can store it in a different table. But in this case, because you like if I say section B, it doesn't have any meaning, right? If I tell you, for example, course 3421, you can tell me this is database course. If I tell you the student's number, you can tell me which student it is, right? But telling section B doesn't, for itself doesn't have any meaning, right? And in order to complete its meaning or its existence, it depends on another entity, which is course. Now, if I tell you course 3421 section B, right? This is clear that we are referring to this course, which I'm the instructor, right? And if I'm telling you 3421 section A, right? This is a completely different course, right? So, course and section together can identify the section completely. Now, in terms of designing your ER model, how do you want to take care of that? So you can consider it as a weak entity. So as I mentioned, weak entity means an entity that doesn't have its own primary key, because let's say I have a section, right? This is a section. And I have a section number. But is it a primary key? Not really. It doesn't have any meaning. It cannot uniquely identify sections, right? Because if I say section B, could be for database course, could be used for Python course, could be for machine learning course, and so on. So it's not only about you say, okay, I have a section, and then here's section N, A, B, and so since these are unique, so this is a primary key. They do not have a unique meaning, right? They cannot uniquely represent each instance of that entity, which is a section, right? But together with the course ID, right? They can represent each course and section specifically. So if you want to refer to my class specifically, this is 3421. Section B, for example. Another instructor could be 3421 section A, right? Together they form, they have a meaning. So a weak entity, how do you show that? You show it with a double line rectangle, okay? So double line rectangle means a weak entity. In most cases, like in most examples, you may not have to even deal with it. So most of the time you don't have that. But sometimes this is one way to handle these cases, such as, for example, section number, or like entities that do not have any meaning with themselves alone. Okay, such as this case. And so let's quickly go through here. I want to just make sure that I didn't miss anything. And have you tried ERDPlus yet? Yes? How many of you tried ERDPlus? Okay, thank you. Only a few. Okay, so please, if you have, how many of you have your laptops with you now? Okay, great. So let's go to ERDPlus.
already messy. So let's say like when you're really looking at this text there's like I said, what I said. That's what I'm getting at. So I want to like implications of self-evident. So I guess
So as I mentioned before, you have the option to sign up, which I recommend, because if you sign up, they changed their interface from last year or previous semesters that I was using, but everything is like a function in terms of functionality, it's the same. So if you click on try it, right here, you can draw your ER model and. But I think I'm not sure if you can save it. They also add the save option here. So maybe without logging, you can have, because previously, if you signed up, which is free and very straightforward and easy, then you could save all your ER models there and then you could access them later. But I don't know if that's the case anymore. Anyways, let's say I want to add an entity. So click on entity and then write the name here. For instance, let's say this example. So let's say we have an entity, just click here, and then it's a student, right? Now, if you want to add another entity, again, click on entity, right? You can drag it here, add, for example, a course entity. And as you see, you can also identify the type of the entities here, right? So right now, a student and course, they are both regular entities, right? So I just put them and leave them as they are. But we have also weak entity, associative, and subtype supertype. So let me also quickly explain subtype supertype. So sometimes you have different types of one entity. So for instance, let's say you have, you want to store students in your database, but you have, for example, international students, unlisted students, and so on. You want to store employees, right? But you have different types of employees, like part-time, full-time, contract, and so on. And they may have different features, okay? So this is where you understand that you want to use subtype supertype. So for instance, for maybe for example, contract employees compared to, for example, the full-time or tenured employees, you may have some different features, right? So that's when you use subtype supertype, and this is how you show it. So for instance, let me show it in ERDPlus. So for a student, for example, let's say I identify it as subtype, okay? What could be the this is a supertype. What could be the subtypes of a student? What type of a student you may have in your database? Can I have, for example, domestic international, right? And for them, you may store, for example, different features. Maybe you want to like keep, I don't know, passport number of international students while using the same number of the domestic students and so on. So this is how you do that. And then you can add the subtype entity here, right? So for your exam, because this is not a lab test exam and you do it on paper, so you have to know how to represent all of this. That's why I emphasize on a droid on blackboard so that stick into your mind. So for example, this is how you show associative entity. This is how to show regular entity. This is how to show a weak entity. And the weak entity, its relationship with its parent entity should also be shown with double line over. Okay, so everything related to the weak entity, the relationship or the entity itself is double line. Okay, and we call this an identifying relationship. And so for this, you see this sign here. Now this is disjoint, and I'm going to explain it in a bit. So for instance, we can have international students, international, and we can also have add another subtype, right? Domestic. So this is for the student, right? Now let's define some attributes for the student. What can I leave here for the student? Hello everyone. Student ID, right? How can I add the attributes? If you click on the entity, you see that you can add attribute here, right? So for instance, one attribute could be a student ID. Is this unique?
Yes.
Yes, so you sign it, right? So you check the unique here. So it means that this is a unique identifier for this entity. Now adding another subtype, so I just click on it, delete, right? So again, click on student, adding another attribute. Now a student ID, let's say first name. First name. Is it unique, multi-valued, or what? What is the type of first name? And by the way, optional means those attributes that can have no values. Okay, so if you have an attribute that can have no value, that's optional. But we mainly, the most important ones are unique. For all entities, you have to identify one unique attribute. Multi-valued, sometimes you have, for example, phone number. Composite attributes, you can have it in your ER models. For example, if you want to address, a store address, or even name. Actually, name is a composite attribute. Why? Because name consists of first and last name, right? So this is the correct way to show name. So you write name here, identify it, you check the composites, and as you see, the parenthesis appears here, right? Can you see it, or should I zoom? Is it okay?
Yeah.
Okay. So now you have name, which composed of first name, last name. Now, the components are first name and last name. Add another component attribute. So you see, for whatever entity or attribute that you want to add something, you have to first click on that. So if I want to add an attribute or component attribute to this attribute name, so I have to first click on this and then component attribute, and then you add last name. And So this is about the name. Address would be the same. So address is also composite attribute if you wanna also store that. You can add several other attributes for a student, right? Email and so on. So for now I keep it as is. And one more thing about subtype supertype entities. So all the subtypes, for example, domestic and international, inherit all the attributes of their supertypes for their parents, which is the student, right? So for instance, whether it's international student or domestic student, they all have a student ID, they all have name, and any attributes that appear here for the student, right? They inherit all. But they can have their own specific attributes. So for example, for domestic students, you may want to store, I don't know, passport number or country, right? Whereas for international students, you may want to store country, passport number, etc. Whereas for domestic students, you want to store only SIN number. And so if they have like any separate attributes, you identify it here. So for example, here, there's a SIN number. And what else? I'm still a bit new to this new interface. So what about course? What are the attributes of the course? Adding attribute, like what is the type of the course entity? Course ID. What is the type? The type of the course ID is here. And then course name. Is course name a composite attribute? Yes? What is a composite attribute? It's composed of several attributes itself, such as a student first, a student name, which is first and last name. Someone's address, which is a street name, a street number, zip code, and so on, because they compose of different attributes. So is course name a composite attribute? Who said yes?
Because it consists of sections.
No. Course name doesn't compose of different attributes itself. Course name is a course name like Introduction to Database Systems, right? Course name is artificial intelligence, machine learning, and so on. So course name is just regular. And then we have, what else we have? Anyone want to come here and try? Anyone to come here and finish this? I give him 0.01. No, this will add up at the end. And then when you email me, oh, my grade is like 89.9, please like make it 90 so that I'm A+, so it's counts, right? So anyone coming here with a bonus point? Yes. Yes.
Are these entities part of the hypothesis?
No, here you can try this. Maybe I can What don't you know? Yeah. So, sorry, what was your question? Which entities are part of?
Are we entities part of composite keys? Basically, composite keys are keys that are composed of
You mean composite primary key?
Yeah, primary key.
So this entity, as with like the name suggests, is an entity, right? Representing a thing, person, a place, something like that. So it's an entity. Whereas composite primary key is a primary key, which is an attribute, right? Attributes provide further characteristics about each entity. I think you have to. Yeah, just one. Yes, now. Yes. So if you want to show the relationships using ERDPlus, you have to enable the connect here to show them here. So you can enable the connect first, and then drag, for example, from course to the student to show the relationship, right? This is how like do it. And then you have to again disable connect if you want, for example, add attributes, entities, and so on. So that's why you have to practice with it. Yeah, so students can do roll before, and then we can identifying a relationship is what we can now here, because we know that the student was having many relationship. You can show it as many students for now, and then I will let you. Okay. So you can identify that in the cardinalities down. Yeah. So this is minimum and maximum cardinalities, which shows if it is mandatory, optional, etc. And then there is one. Yeah, you can try. So if you put it, for example, now here, it shows that each course, right, should have at least one student enrolled in that course, which is correct. And then put many, which means each course can have many students enrolled in that. Now you have to also do it for the other side. Oh. Yeah, you can select the entity there. So as you see, on the right side, you see edit cardinalities 4. So for whichever entity that you want to show the cardinalities, you have to select that one. So for example, now we selected the student, right? So we can show whether it's optional or mandatory in that side for the student side. Now we can change it to the course. Okay, you did both. Yeah. So you can just, this is where you can change for both courses. So this is a many-to-many. So for many-to-many, you have to use associative entity, which means instead of this relationship, you have to create an entity. So add an entity. Don't delete that for now. Yeah. So add an entity. You can write it here. And we call it enroll or enrollment. Because this entity is better to use a noun, right? And then enrollment is an associative entity, right? Yeah, the mouse is weird. Maybe it's here. Alright. So the associative entity, and then connect associative entity to the course and student. I don't want you to do it now because I want to show you something. Even if you don't add the associative entity here and leave your relationship between the student and course as many-to-many relationship, later I want to show you when you convert it to your relational schema, it shows you the tables. It adds a third table, which is enrollment. That is automatically adding the third table or the associative entity for you. But for the sake of like this course, the exam, your project, and everything, I'd like to ask you to please specify that in your model because I want to see that you understood that you have to use associative entity or third table, right? I mentioned this because last semester we had students and they said, okay, the ERDPlus already converted that, so we had the table, so it's fine. No, it is not fine because we expected you to show it in your model, okay? So for now, you can keep it as it is, just to save time. But in your actual assignment and project, please show that with associative entity. Okay? Yeah, you can can just implement. Yeah, please. Yeah, and then now you have to identify relationships.
So that's many.
And always, when you're using associative entities like this, you always see the many sides close to the associative entity. Okay? So, I want to just summarize a few points or notes or hints or tips for associative entities. First, you use associative entities, you can continue. You use associative entities whenever you have many-to-many relationship. Second, always the many sides are close to the associative entity because it actually broke down the many-to-many into one-to-many. Third, the minimum attributes that you have to identify for each associative entity, regardless of whatever the context is or whatever the model is, always associative entities have at least 2 attributes. And what are those attributes?
The primary keys from the too many to many tables we're looking at.
Yeah, the primary keys of the 2 tables that is connected, right? Because when you connect 2 entities, what happens? The primary key of one, when you connect or link 2 tables, how do you link them? Through foreign keys, which means the primary key of one table is added to the other table as foreign key. For instance, at the beginning of the class, when we wanted to connect the professor and the student, right? We said in our actual tables, in order to represent that relationship or that connection, we have to add the primary key of one as a foreign key to the other table. And that is we always add the foreign key to the many side, right? Because each student is supervised by only one graph. Yeah. And now let's also practice with the weekend key. So you can have like class section. Yeah, you can refer the show entity, add an entity. Yeah. And then the entity could be section. Or like class section or class something. And then yeah, this is a weekend. So this is a weekend key shown by the double line rectangle. And then its parent is the course. It should be identifying, so you should check the identifying there. So this is how you represent identifying relationship in ERDPlus. What is an identifying relationship? I really like the fact that I cannot attract your attention for even like 1 minute straight, right? So what is an identifying relationship? Yeah?
It's like a conditional kind of entity. Depends on parents' parents.
Yes.
Is it a relationship between 2 weak entities?
Partially both are partially correct. It's identifying relationship. So it's a type of relationship, right? And this is a relationship between a weak entity and its parent entity, not between 2 weak entities, right? For example, between section, which is a weak entity, and its parent entity, which is a course, right? And you can think about like all these in terms of your assignment or your project. So for example, for your assignment is I think it's a flower shop, right? So you have a product, right? And again, it depends on your assumptions. You can make simplified assumptions to some extent, not simplify too much and then expect a full score. But the model, like if you want to implement the actual database, is very complex. You can like build something in between. I already specified, I'm going to release assignment 1 soon, and I provided some tips for you and mentioned specifically which parts you can make simplified assumptions, okay? So for instance, you have an entity for your products, which are flowers, right? But products could have product components, different product components, or different categories, and they can use for different occasions. So these are all different entities that you have, for example, for your assignment 1. And then you can think about what are the attributes of each entity and the type, what are the relationships. For example, you want to keep track of users or customers' data, right? So one entity is always for the customer, for the users. And again, if you want to send flowers to someone, right, you may want to also keep track of your recipients, right? Sometimes sender and recipient are the same person, sometimes they are not. So these are the things that you have to think about when you want to actually design your database. Well, I'm talking about your assignment, assignment 1. So for your assignment 1, I asked you to draw an ER model for an online flower shop. So I give you the link to the flower shop, and then I want you to do reverse engineering. And what does that mean? You go to the website, you see what functionalities are available there. So for example, you see that you can browse the catalog of flowers, and then there are different types of flowers. They also have some complementary products, vases, etc., etc. How do you want to handle that in your database? So basically, you just check the website, the application, and then see what functionalities are available. And then you always start from something simple, okay? Don't overwhelm yourself. Just think about what are the main entities or what are the main things that you want to keep track of in your database. I'm providing more instructions for you in the section. Okay, so you have it for section is a weekly routine. You identify the relationship? Yeah. That's perfect. Thank you so much. Yeah. So this is not complete yet, but at least you got some ideas. Yeah. You also should give me your name. So, we are done for today. Next session. So please read the slides for lecture 2, these slides that I covered today. I think I almost covered everything, but you have to practice in ERDPlus, okay? You practice more.
Yeah,